Welcome, everyone, and thank you for joining us today. This session is titled Assessing Pitting in Pressure Vessels, with a focus on a practical example as per API 510. Let's start by understanding what pitting corrosion really is. It's a localized form of metal degradation, where tiny but deep cavities form on the surface. These pits often happen because of things like chlorides, stagnant water, or certain environmental factors. The crucial point is how these pits impact the vessel's strength and its safe service life. So, when assessing pressure vessels, we focus on how these pits might reduce integrity, not just their appearance. Now, API 510 gives us the rules we need for inspecting pressure vessels in service. It offers clear screening criteria to decide when widely scattered pits can be accepted without jumping straight into detailed fitness for service analysis. The key is meeting all three conditions. The remaining thickness under the pits must be more than half the required thickness to avoid leaks. The total area of deep pits can't exceed 7 square inches within any 8-inch diameter circle, preventing clusters from acting like a single large thin spot, and the sum of pit widths along any straight 8-inch line can't be more than 2 inches, so pits don't behave like cracks. This helps us balance safety with practicality. Let's apply this to a real example. Imagine we find pitting on a vessel's shell during a routine inspection. The vessel has a nominal thickness of 1.25 inches, with a corrosion allowance of 0.125 inches, and a required thickness of 1 inch. Within an 8-inch circle, we spot 3 pits, depths ranging from 0.15 to 0.4 inches, and diameters from 0.4 to 0.6 inches. Our job is to see if these pits meet the API 510 acceptance criteria or if further evaluation is needed. This sets the stage for a practical check. Here's how we evaluate those pits. First, we check if the remaining thickness at the deepest pit is more than half the required thickness. Calculated, that's 0.5 inches, and since the remaining thickness is 0.85 inches, this passes. Next, we total the area of pits deeper than the corrosion allowance. Adding up the areas, we get just over 0.6 square inches, well below the 7 square inch limit. Finally, we sum the pit widths along an 8-inch line, which totals 1.5 inches, under the 2-inch max. Since all criteria are met, the pitting is acceptable for now, but monitoring is essential to catch any changes. To wrap up, API 510 provides a straightforward 3-step test for widely scattered pits. If the pits don't meet these criteria, a more detailed assessment under API 579 is necessary. When pits are acceptable, it's important to document and monitor them to protect vessel integrity over time. If they're not acceptable, immediate action is required, whether that's further analysis, repairs like grinding or patching, or operational changes such as derating. This approach helps ensure safety while managing maintenance effectively.